Here are the first 12 elements of the periodic table, or the first 12 elements, and by first 12 I mean the increasing number of proton number, right? You have the smallest atom possible with only one proton, no neutrons and electrons to match. Okay. The one after that is helium with two protons and two electrons and two neutrons. Okay. Notice how their mass just jumps. It's not 2 anymore, it's 4, because you also have neutrons only as well. You have 2 neutrons, 2 protons, total masses 4. And 3 and 4. Notice how the neutron number does not match anything. There's no way of predicting the neutron number. It kind of follows, it's roughly the same as the proton number, but not true. I think after magnesium you'll see a lot of elements where the number of protons just does not match the number of neutrons. Just don't think it's gonna match or find a pattern to it. This is all random, more or less. It kind of matches the number of protons, but other than that, pretty random. And the heavier you get, the larger you get with more protons, you'll find these values just become really ridiculous. Okay. But the electron number matches. Number of electrons will always match because the charge needs to balance out. Okay. So you got a hydrogen and helium and lithium and beryllium. I could go on, but I want you guys to complete this lecture. Okay. So they're all here, but you know what? This is a really poor way of representing all the atoms. Maybe it's useful for some way, but it does not give me any direct information, and it's kind of, this entire page is taking all the space, so it's not the best way to represent a lot more elements in one concise manner. Another thing is we're trying to understand how they react and everything. So one thing you ended up noticing, how people started when they were working on chemistry early on, like 18th century people, scientists, they started realizing that these atoms, their properties or how they react, their chemical properties especially, it repeats and repeats in every 8 or so elements, right? Not a strong rule, but generally that's the case. Okay. So they started pairing them up. So they realized that I think hydrogen and helium are kind of outliers. They don't really fall into that category, but we kind of push them into a category. But lithium is very similar to, let me change the pen type I have. Lithium is very similar to sodium in properties. Then you have beryllium, and notice how sodium is 8 away from lithium, right? Then you have beryllium, which has very similar properties to the atom which is 8 away from it, and that's the one right after magnesium. Okay. And this goes on, this list, I couldn't fit any more atoms, but boron had very similar properties to the other element, which was aluminium. Okay. And so on and so forth. It kept going, and it kept repeating again and again. Every 8 or so, when you were done with neon, it would repeat again, right? So lithium, sodium, and the 8th after sodium would all have similar properties. Okay. So let's find a few elements using, well, what do we use? I guess periodic table, and let's try to arrange them in a way where their all properties are lined up. Okay. So if they're repeating in 8s, we'll need a table with 8 groups, right? Or 8 columns. And let's start with there. Let's see where that goes. So I just said hydrogen doesn't really fall into a category, and neither does helium. Okay. And we'll kind of try to force them onto this row, but yeah, they don't really fall into the category. Okay. So I'll leave the first row blank because we'll try to fit helium and hydrogen as we see fit in a bit. But let's start with the third element, lithium. You have lithium, and let me just cheat a bit and look at the periodic table. How many protons does the lithium have? Lithium has 3 protons. Okay. And after that, you have beryllium with 4 protons. Okay. Then boron. I find boron really funny, right? Carbon with 6 protons. Nitrogen with 7 protons. Oxygen, my favorite. Carbon actually is the top, one of my favorites as well. 8 protons. Fluorine with 9 oops, that's not a 9. 9 protons. Neon with 10 protons. Okay. And remember, sodium was right after. So this group, like sodium, had very similar properties to lithium. And where do I add the next element? Because it's in a group of 8 and I'm adding them horizontally. Of course, I have to go to the next line, and lo and behold, they start pairing up. So both lithium and sodium have similar properties. And if I start adding more elements, you'll see all of them are paired up. So let me just change the color to make this a bit more interesting. Let's try pink. I need to diversify my color range. Sodium is 11. Then magnesium, which is very similar to beryllium, is 12. I wanted to write 12, but I wrote 2 first for some reason. Okay. Boron के बाद aluminum has similar properties, which is 13. Look how neatly the proton numbers are increasing. It's just in order, but the properties are repeating and they're all in one line. So all of this column has similar properties and all of this column have similar properties. All of these elements in this column will have similar properties. To know how lithium reacts is to know how sodium reacts and how potassium reacts. Potassium's right here. And all of these, right? So that's how powerful this table becomes. And let's keep on going. Okay, let's finish this. We have aluminium. Then we have silicon. It's not an S. Silicon with 14. Phosphorus, 15. Sulfur, 16. Fluorine ke baad, I think it's chlorine, which is 17. And I think argon is the last one, 18. Okay. And let's just add 2 more. Let's force 2 more in there. Potassium, because it's kind of important, keeps showing up, 19. And I should change the color. Potassium, which has 19, and calcium, which has 20 protons. How many electrons does calcium have? Quick question. 20, right? Okay. Now, if you want to arrange these in terms of properties, they don't really fall anywhere, but you end up putting helium helium over here, which has 2 protons, and you have hydrogen, which they'll either sometimes they'll put it here, or they won't put it anywhere, so they'll just keep it on top of the periodic table. Funny how I use that word, periodic table. Why do I put the one over there? It's at the bottom. Take it. Now, these properties are repeating every 8 or so. Take it. If you don't want to say, you want to say after every periodically, these properties repeat. So they end up calling it the periodic table. Take it. Now this I find very interesting. Now Mendeleev was born in 18th century, was a scientist, chemist, who was attributed, like a lot of people tried to put elements in tables, right? And he was one of the first whose periodic table, which how he decided to arrange them, was shown the most, it was the most logical, the most useful of the periodic tables they had, or table of elements. So this one got really popular. So Mendeleev was the one. Now, I'll tell you how good this is. At that time, they hadn't discovered too many elements. I think oxygen was one of the elements that wasn't discovered. People didn't know about oxygen, even though, you breathe it and whatever. And so he had like 8 or 10 elements, and he arranged them so. Didn't have a lot to go with, but he arranged them so, and he said, these blanks, these missing spots on the periodic table imply these elements exist and we haven't discovered them yet. Very bold statement. Okay? And during his time and after his time, people kept filling these tables up. He was right. He went so far as to predict their chemical properties as well. So oxygen ki chemical property he listed down. It's reactive, it's this, it's that, ऐसा होगा, ऐसा होगा, ऐसा होगा, ऐसा होगा. And he was right for the most part, right? And he was right for other elements as well, which were still being discovered, hadn't been discovered at that point. So that's the power of the periodic table, how useful it is. You look at the element, any element, and knowing its column and its period would be the row it's in, column is the group it's in. Okay? You know how that element reacts just by the virtue of its position. So getting comfortable with the periodic table is something I'd highly encourage.